All right, I'm not sure that anyone would be interested in this, but I decided to do another video that just shows quickly a little bit on digging into this area of a regular polygon formula. So in class, I probably would have spent some time on this, but I am trying to keep the lessons a little bit shorter so that maybe people will actually watch the videos. And so this is going to dig into this idea of regular polygon formula, the area here. So the way that we have looked at it is this first formula, though a different way to look at it would be the second, and I've mentioned that before as well. This is the A is for, the big A is for area, the little a is apothem, and P for perimeter. Or we can look at it this other way. The two A's are still the same. N is the number of sides of the polygon, and S is the side length. Note that when you take the number of sides times the side length, what do you get? You get the perimeter, right? N times S is perimeter, right? So it's not special, it's not really different, but for some it is easier to look at it that way. Okay. Now what I want to do is to show maybe a little bit better what we're actually doing. Ooh, this is a terrible, well, I didn't pull it together much. All right, this is a regular hexagon. You don't believe me? That's okay. We're going to pretend that it is. Now, what if we wanted to find the area of this? And say we didn't know either of these two formulas, right? Well, what might we do? We might break this up into a bunch of shapes that we do know how to find the area of. Now again, remember this is regular, and so all of these 6 triangles should actually be the same, right? So they don't look the same in mine, but they are the same. So each of these 6 triangles have the same area, and each of them have the same measurements, right? Now, how would you find the area of one of these, right? If I just wanted you to find the area of this, well, it's just a triangle, right? So a triangle means the area is 1/2 the base times the height. And well, it's not just a triangle here, right? Because this is a hexagon, right? This one specifically, we draw in the height. Oh, notice that the height of the triangle, or any of these triangles, is actually equal to the apothem. They're the exact same thing, right? So that should be seen as something that's at least a little bit interesting, right? And what is the base? Well, the base is this. That's the side, right? Base length of the triangle is the side length. Well, if we find the area of one of them, right? Well, all we're doing is finding it 6 times, right? It's the same thing 6 times in this one, right? In a different problem, it would be 5 times or 8 times or something like that, right? But it's just all based on this, well, not necessarily a 30, 60, 90 or regular triangle. It works for any triangle. But it's all based on that these are the same things, right? So what's the area over here? Well, the area is, well, we have 1/2 the base, right? But that's actually the same thing as a side length, times the apothem, times, well, how many triangles we have. Well, we have 6 of them, but it's not just 6, right? This is a hexagon. It has 6 sides. So if we wanted to sound silly, we would say something like this is a 6gon, right? Because n is 6, right? Well, we have 6 of them. If it's an 8gon, n is going to be 8, and there's going to be 8 triangles, right? So we have 1/2 for the area of the whole thing, 1/2 a side length times the apothem times the number of sides. And lucky for us, multiplication is commutative. Multiplication of numbers is commutative. Different day. And again, NS is perimeter. So why is the area of a regular polygon 1/2 the apothem times the perimeter? Because triangles, right? Because of triangles. And that is why this formula works.